So students, for our last test that we're doing here, we're going to do a TLC on our compound. So I have here my plain cyclohexane, and I'm going to go ahead and spot 2 applications onto our TLC plate for each of the compounds that I'm about to do. So let me go ahead and set this down. And we will have 1 and 2. Okay, so that is just plain cyclohexane by itself. Next up, we will do cyclohexene. So let me grab my spotter for cyclohexene. Okay, and cap my solution. And for comparison, we're going to see what the TLC would look like for the compounds that have reacted now with potassium permanganate. So we're going to take a small amount of the cyclohexane with potassium permanganate. I'm going to place this down as our 3rd spot. Okay, and lastly, we're going to do the cyclohexene with potassium permanganate. Now this one I'm going to press down a couple extra times just because it does have precipitate in there, and so it is a little difficult to get it onto the plate. Okay, we're going to set this into our TLC jar and take a look at what our compounds look like after the solution has traveled up the plate. Here, let me know when you're done. All right, so our solution here is a mixture of the hexanes and ethyl acetate. So I'm going to go ahead and place our plate in here. So we have a ratio of 2 parts hexanes to 0.5 of ethyl acetate. And as the solution moves upwards, we may or may not see the spots on the TLC plate move, but we will be back in a moment to see what happens to our compounds after the solution has risen to the top. So I just took our TLC plate out of our resolving jar here, and so right now it appears as if nothing has moved, but we're going to go ahead and stain our TLC plate here and see if we can get any of the spots to appear on the plate for us. So I have here some potassium permanganate stain, and it's a fairly dilute concentration, so we got 0.2 molar potassium permanganate, and I'm going to go ahead and dip my entire TLC plate into the stain, and I'm going to go ahead and tilt it forward so that the entire plate is stained with the solution. And as we bring it out, I'm going to place it down on my paper towel here. Notice that we have some spotting that has occurred. So for the first column where we had placed down just cyclohexane, nothing has appeared there. But here for cyclohexene, we see not only the cyclohexene itself, but the spotting for where it may have reacted with our bromine solution. So we have technically 3 different spots going on right here. Lane 3 had cyclohexane with potassium permanganate, and it looks like nothing occurred there, but this last spot where we had cyclohexene with potassium permanganate, looks like our spot kind of warped sideways, and that's all right, but this is showing us that yes, we now have a new compound that formed when cyclohexene reacted with either bromine in water or potassium permanganate.